The first step in the layout process is to identify and mark the locations of the supports located below the subfloor. This will help determine the best location for the pan. In certain installations, it may be necessary to shift the pan so the drain doesn't conflict with the supports below. Once the best position of the pan is determined, mark its exterior edge to represent the area of subfloor that needs to be removed. Keep in mind, on new construction projects, with a little pre-planning, the framer can easily offset the floor supports to either side of the desired drain location. Prior to cutting the subfloor, adjust the depth of the saw blade so it cuts just deep enough to penetrate the wood. This helps avoid causing damage to any items located beneath the floor. The cuts have been completed so the subfloor can be removed from the shower area. If there's any construction adhesive or wood scraps remaining on the top of the floor supports, that should be removed as well. You'll notice in this installation that there's plumbing pipes that need to be framed around. This is a fairly common occurrence, and one that's easily corrected with little effort. To begin the process, start by adding 2x8 cross braces at each end of the opening. It's also helpful to have a few small pieces of 3/4 inch plywood that can be used as guides while performing the framing. Once the cross braces are in place, add a 2x4 ledger board to the face of the existing floor support. This board should be installed so it's 3/4 inch lower than the top of the supports. Next, we'll install a 2x8 at the other side of the opening in order to create a pocket for the plumbing pipes to pass through. You'll notice that this board is raised so it's flush with the bottom side of the existing subfloor. This ensures that there's proper support under the existing floor. After the 2x8's been secured, add a 2x4 to the face of it as well. This board should also be dropped 3/4 inch below the top of the floor supports. The framing is complete in the first bay opening, so we can set the 3/4 inch plywood on top of the ledger boards. Prior to installing the plywood, we recommend applying construction adhesive to the top of the ledger boards. You'll notice that the piece of plywood being installed has been cut a few inches longer than the actual opening, so it can be slid under the existing subfloor on each end. We'll finish the framing in this area by screwing the plywood down into the top of the ledger boards. We'll also screw down through the existing subfloor at each end, tying the two plywood floors together. As you continue to watch the framing being completed, we'd like to share some of the significant advantages that the Vim level entry shower system has to offer. There are several competing companies claiming that their products can be used to create curbless showers. The scary part is how they nonchalantly instruct installers to simply cut several inches out of the existing floor supports in order to compensate for the thickness of their products. This is a dangerous recommendation that could compromise the structural integrity of your home. Modifications like this should never be done without consulting with and obtaining prior approval from a structural engineer. Many of these same companies are misleading consumers to believe that their systems are the cheaper alternative. It's unfortunate that their marketing tactics will undoubtedly convince some customers to purchase their system. What they fail to disclose is that you must also purchase their expensive wall panels and accompanying products in order to maintain their system warranty. As you begin calculating the cost of these expensive add-on items, their cheaper alternative isn't so inexpensive after all. By comparison, the Vim level entry shower system was designed to be installed using standard backerboard material without affecting its industry-leading 10-year product warranty, and installs without having to cut, notch, or lower any of the supports under the shower floor. This makes the Vim shower system the best solution for homes constructed with I-joists and engineered trusses, and its minimal thickness makes it ideal for concrete applications. Okay, let's get back to the video. The balance of the framing was performed using the same techniques we used earlier, the only difference being the two cross braces that have been added on either side of the drain location. The framing for the 3/4 inch recessed platform is now complete. As you have seen in the video, the supports located below the shower were never cut or compromised during this process. This shower layout will utilize the full 5-foot by 4-foot pan that comes with the Vim system. If an installation requires cutting the pan, cut lines have been molded into the pan's surface for the installer's convenience. These lines are for convenience only. The pan can be cut to any size and any angle to fit just about any size shower. In the event that the pan has to be cut, dimples in the pan's surface mark the preset countersink points. These dimples allow installers to quickly identify and add new countersink holes as needed. Set the pan in place and mark the location of the drain on the plywood. You'll notice that the drain receptor extends slightly below the bottom of the pan. We suggest cutting an 8-inch hole in the subfloor to allow a small amount of play around the drain. Once located, simply cut the hole with a reciprocating saw. On installations where access isn't available from below, the drain pipe and the hole in the plywood would need to be completed prior to screwing down the plywood. Before we continue, it's important that we clean the work area so there's no debris to interfere with the pan's ability to set completely flat on the floor. The Vim shower pan was designed with a built-in slope of 1/4 inch per foot. This code-required pitch starts at the corners and slopes towards the drain. Because the pitch is built in, it's imperative that the pan is installed level. Set the pan in place, press down on it, and check it in all directions with a level. Remove any areas that cause the pan to teeter, and take note of any low areas in the floor that we'll need to compensate for later. As part of the installation process, the Vim shower pan is installed in a bed of modified thin set. A full-size pan installation will typically require a little less than 2 50-pound bags thin set. The thin set helps fill in any voids caused by framing irregularities. It aids in the leveling process, creates a chemical bond between the pan and the floor, and ensures the integrity of the entire system, even under the heaviest of weights. Fill the back side of the pan with the modified thin set, and then apply a thin layer to the recessed area. Additional thin set should be added to any low areas that were noted in the floor when the pan was being checked for levelness. Carefully set the pan into place and avoid stepping on and compressing any areas where additional thin set has been added. Begin screwing the pan into place, starting with the 4 center holes located near the drain. These 4 screws should be tightened so they draw the pan down tight to the floor. Finish by screwing down the perimeter screws. As you're tightening these screws, keep a level on the pan surface and tighten the screws until the pan is setting completely level. Once the pan has been secured, tile backer board can be added to the wall and floor areas. For the benefit of the other trades, and until the required inspections have passed, the backer board on the walls should be installed no higher than 18 inches above the floor. For this installation, we'll be using 1/4 inch backer board underlayment on the bathroom floor. Once installed, the 1/4 inch backer board will sit roughly 1/8 of an inch higher than the pan. In order to maintain the 1/4 inch per foot slope built into the pan, we'll hold the backer board about 6 inches away from the edge of the pan. The sloped transition between these two areas is easily accomplished using one of the quick-drying patch materials recommended in the installation manual. These patch materials are specifically designed to be used for this type of application. Thin set should never be used for this purpose. In designs where a larger shower is desired, this can easily be accomplished by increasing the thickness of the backer board used on the bathroom floor. For example, by using 1/2 inch backer board on the bathroom floor, it adds an additional 1/4 inch in height. This additional height results in the pan's pitch being able to be extended an additional 12 inches. Remember this math. When using 1/4 inch backer board, the pan's pitch to be extended by 6 inches, while using 1/2 inch allows it to be extended by 18 inches. All of the parts required to install the drain are supplied with the Vim drain kit. Using the tube of silicone provided with the kit, thoroughly coat the bottom of the drain assembly, making certain there's complete coverage around all of the screw hole openings. This is the only place the silicone is used, so use it all. Insert the drain assembly into the pan and spin it until the engagement tabs allow it to fall into place. Once in place, the screw holes will automatically be lined up for you. Secure the drain assembly with the 6 stainless steel screws provided. These screws should be hand tightened using a crisscross pattern. Once the drain has been secured, wipe any excess silicone from the pan surface. This installation is fully accessible from underneath, so we can install a short piece of 2-inch PVC pipe in the drain assembly and then make the final connection from below. We'll coat the outside of the drain gasket with the tube of grease provided in the kit. Then we'll slide the gasket over the pipe until it's flush with the top of the pipe. This gasket has a flat side and a beveled side. It's critical that the gasket is installed with the beveled side facing up. Using the lock ring tightening tool provided, push the gasket into place. Once the gasket's set, flip the tool over and attach the lock ring to it. Hand tighten the lock ring until the gasket is secure. For installations where access isn't available under the shower, The following step details how to make the drain connection when the pipe's already been stubbed up through the floor. The drain gasket installs and tightens into place the same way we illustrated earlier. Using an internal pipe cutter, cut the pipe from the inside out. This tool can be purchased from most plumbing wholesalers or do-it-yourself centers. If this is your first time using this tool, it may be easier to start the first cut a little high and then work your way down the pipe. The final cut should be made just above the lock ring. Remove any plastic burrs remaining after the cut is complete. Prior to starting, cut strips of the mesh matting provided in the waterproofing kit and lay them loose on the floor between the pan and the backer board. Follow the manufacturer's instructions when you mix the patch. If the patch is being applied over anything other than plywood, a thin coat of waterproofing should be applied to the area first. The patch materials that we recommend are specifically formulated to dry quickly and resist shrinking. They can also be troweled to a feathered edge, which means that the patch can be extended onto the pan surface if need be. Because the patch dries quickly, it's important that everything is prepped and ready before the patch is mixed. Trowel a rough layer of patch into the area being sloped. As the patch begins to set up, it will become easier to work with. Now that the patch is set up some, we can start smoothing it to a finer finish. As we're working with the patch, we'll follow the slope built into the pan surface to ensure we're maintaining the proper pitch required. We can accomplish this by using the trowel as a straight edge between the pan and the backer board on the wall. At this point, the patch is close to being finished, and since the slope on this installation was calculated from the edge of the pan, we'll clean the excess patch back off the pan surface before it dries completely. A damp sponge is a useful tool to help even out and smooth the patch. As a final touch, a trowel can be used to smooth out any last little imperfections. The patchwork is complete, so we'll stand back and allow it time to dry thoroughly. As it dries, the patch will begin to turn chalky white, letting us know that it's just about ready for the waterproofing to be applied. Before starting the waterproofing process, pre-cut all of the fabric pieces. Creasing the 6-inch fabric ahead of time makes it much easier to install into the seam areas. For the corner pieces, cut 6-inch square pieces of fabric and then cut them halfway up the middle. These fabric pieces can now be folded to form the seals for the corners. Now that all of the fabric pieces have been pre-cut, the waterproofing process can be started. The first step is to apply a thin layer of waterproofing to all of the seams. This first coat should extend 5 inches up the wall and 5 inches onto the shower floor and continued around the entire shower. While we're waiting for this first coat to dry, we'll continue waterproofing the remaining wall area above the pan. The first coat of waterproofing is dried, so we can move to the next stage. We'll apply another thin coat of waterproofing to the seams before inserting the 6-inch fabric strips. The fabric should always be placed into a wet layer of waterproofing. If it begins to dry before the fabric's been inserted, simply peel back the fabric, recoat the area, and then reinsert the fabric. The fabric should always be installed so it's tight in the seams. The brush supplied in the waterproofing kit can be used to tuck the fabric into the seams. After smoothing out the fabric, apply another thin coat of waterproofing to the top side of the fabric. After the floor-to-wall seams are completed, the corner seals can be installed. Apply a thin layer of waterproofing to the corner area. Insert the corner piece and peel back the overlapped fabric piece. Waterproof under the fabric flap and then smooth it out. When it's complete, this seal should be tight in the corner. Continue with the vertical seams by first applying another thin layer of waterproofing. When the vertical fabric strips are installed, they should overlap the fabric used for the corner seals and the wall-to-floor seams by a minimum of 1 inch. The seams are complete, so we can move on to the shower floor area. Starting at the rear of the shower, apply waterproofing to an area slightly larger than what the large fabric will cover. As the waterproofing is applied to the pan, it should be done so using a mopping motion. This ensures that the waterproofing is thoroughly embedded into the pan's textured surface. When we get to the area around the drain, we'll apply the waterproofing so it partially covers the drain, being careful to avoid waterproofing directly over the screw grommets. Once the area is completely waterproofed, we'll quickly recoat the area to ensure that it's uniformly wet before inserting the large fabric. Install the fabric as if you were putting a sheet on a bed. Once it's in position, peel back one of the rear corners and slide your hand from the drain towards the corner. Continue working each corner until the fabric is completely smooth over the entire pan. The first section of fabric is installed and smoothed out, so we'll apply another thin coat of waterproofing over it using the same mopping action we used earlier. Once we've thoroughly worked in this top layer of waterproofing, we'll quickly go back over the entire area so we have a smooth, consistent finish. Since the first sheet of fabric we applied wasn't large enough to cover the entire shower floor area, we'll need to add a second sheet. This additional sheet of fabric will need to overlap the first by a minimum of 1 inch. On this installation, it's worked out where our fabric will actually be overlapping by about 12 inches. This is perfectly fine. There's no rule on the maximum distance the fabric can overlap. You'll also notice that we've extended the waterproofing and fabric outside of the shower area and onto the bathroom floor area. While this is a minimum requirement, it's not uncommon for accessible bathrooms to have the entire floor area waterproofed. After the final section of waterproofing is completely dried, add one final thin coat to the entire system. The final coat will typically dry and be ready for water testing within 24 hours. Refer to the directions located on the waterproofing label to better understand how temperature and humidity affects the amount of time required. The waterproofing is completely dried, so the clamping flange can now be installed. Locate the center of the drain and insert a razor knife down through the waterproofed membrane. Work the razor knife over to the edge of the drain body and then cut the membrane using a circular motion following the inside edge of the drain body. Insert the clamping flange into the drain body, rotating it until the engagement tabs allow it to fall into place. Secure it with the 6 small stainless steel screws provided with the kit. Press down on the screws while turning until they penetrate the membrane. Then hand tighten each of the screws in a crisscross pattern until they are snug. The clamping flange has been designed with a series of weep holes to allow any water that penetrates the tile to evacuate back into the drain. Sealants should never be used on the clamping flange as they can prevent the weep holes from working properly. To water test the system, insert a 2-inch test plug into the drain assembly to prevent water from draining out during the testing period. A temporary dam should be constructed so the shower can be filled with 2 inches of water when measured at the dam. Both the drain plug and plumber's putty can be purchased from most home centers or plumbing wholesale suppliers. The International Plumbing Code requires that the system be flood tested for a period of no less than 15 minutes. During the test, it's normal for the waterproofing to change color. When the system dries, it will return to its original color. After the system has passed its inspection, remove the test plug and drain the water. The temporary dam can also be removed. This process is made easier when a small amount of water is splashed onto the area first. Now that the required inspections have been completed, the remaining wall and floor backer board materials can be installed. The order of installation is the same for every shower and should never be deviated from. The bathroom's floor tile should always be installed first, followed by the shower floor, and finally the shower walls. Following this process ensures that the shower will always have a true level entrance and will never require a ramp up or step down to enter the shower. If the design of a shower will include a glass panel, a shower door, or a shower curtain, these items should always be located so they are setting just inside the sloped area of the shower floor. This helps ensure that the water being used in the shower is directed back towards the drain. We've completed the first row of tile on the bathroom floor, so we're going to jump back over to the shower floor. The first thing we want to do is to check the height difference of the 2 tiled areas. If the difference is greater than the thickness of the thin set being used, a simple secondary repitch will be required. This process is easily accomplished using the same quick-drying patch material we used earlier. A notched guide can be used to simplify the reslope process. The notch made should equal the thickness of the shower pan tile plus the thickness of the thin set being applied. Place the notched side of the guide on top of the bathroom floor tile and the other side tight to the pan surface. This helps create a quick, rough screed of the patch at the proper elevation. As the quick patch begins to set up, it becomes easier to work with, allowing a window of opportunity to finish forming the transition slope. Prior to the patch drying completely, flip the trowel on edge and carve off any remaining imperfections. The elevation difference between the two tiles determines how far the repitch should extend onto the pan surface. The repitch should be extended far enough to allow for a gradual slope of the shower floor tile. Once the patch has dried completely, apply an additional layer of waterproofing to the repitched area. This layer of waterproofing will dry quickly. In most cases, just one additional coat is all that's needed. As you're applying the waterproofing to the repitched area, it should be applied right up to the edge of the bathroom floor tile. The repitch process doesn't take long to complete and will actually save time in the long run by allowing one consistent thickness of thinset to be applied. The Vim level entry shower pan was engineered so it slopes from each of the four corners towards the drain. In order to honor these pitch lines, a 4x4 tile or smaller should be used for the shower floor area. We've chosen a 2x2 tile for this installation. You'll notice how nicely the two tiles line up now as a result of our taking the time to do the repitch area. The Vim drain assembly comes with a dummy strainer that should be used throughout the entire tiling process. It's critically important that this piece be in place while the shower floor tile is being installed. The strainer grate receptor and adjuster is a two-part system that allows the tile installer to alter the finished height of the strainer even after the shower pan tile has been installed. Once the finished height of the strainer is determined, apply a few dabs of thinset to the bottom side of the grate retainer for additional support. After the thinset is set up, the shower is ready to be grouted. The grouting has been completed and the shower's been cleaned. So the last and final step is to remove the temporary dummy strainer and insert the finished strainer selected for your shower. We hope that you found this video helpful and that it's provided you with a complete understanding of just how easy it is to install the Vim level entry shower system.